trade organization needs to appoint 5 officers by random lottery: president, vice president, secretary, treasurer, and media liaison from its 79 members. Of these 79 members, 65 live in the local area and the rest do not. No one person may fill more than one office. Your task is to determine the following things. How many ways can the 5 offices be filled? What is the probability that all of the officers will be from the local area? What is the probability that all of the officers will be from outside the local area? And what is the probability that the president and vice president will be locals, but that the remaining officers will not? In order to solve these problems, which make use of the permutation tool for counting possibilities, we'll look into some of the basic combinatoric functionality of the TI-83 Plus or 84 Plus series of calculators. The first part of this problem calls for us to select 5 people from a membership of 79 in the organization to fill 5 distinct roles. This is a classic permutation. So we open a parenthesis, enter the value of 79, go to the Math Probability menu, select the NPR function for permutation, and supply a value of 5 for the number that we're selecting. Close off the parenthesis, and we see that we get a large number of possibilities for how to achieve this task. Next, we're called upon to compute a probability. Specifically, we want to know the probability that the 5 members of the trade organization that we select to fill the 5 distinct officer roles will come from the local area. We'll have to count up the number of ways we can do this before we can compute the probability. This also will be a permutation, except instead of selecting from the full 79 members of the organization, we select from the 65 who came from the local area. We follow the same process as we did before to do this. Once we've counted the number of ways we can select members from the local area using a permutation, we divide that result by the number of ways we can select members from the trade organization in general, 5 members from the trade organization in general. And that was the value that we computed in the first part of this example. Here's how this works on our calculator. First, calculate 65 NPR5 using the NPR function found in the Math Probability library of the calculator. Then we divide this value by our previous result of 79 NPR5, which also made use of the NPR function found in the Math Probability library on our calculator. Once we've computed this value, we see that it's about a 36% chance. Now we've got one more probability to compute. It's the probability that all of the officers that are selected are going to come from outside of the local area. This is very similar to the previous problem, except now the members that we can choose from only number up to 14. So when we calculate our permutation to determine how many ways we can select 5 members from outside of the local area to fill the 5 distinct officer roles, we'll be selecting from a pool of 14. Because this computation is so similar to the previous one, we'll simply copy and edit our previous entry by hitting the second entry buttons on the calculator. All we have to do is change the 65 to a 14 and re-enter the computation. This time we see the probability is much smaller. Lastly, we're computing the probability that the president and vice president that we select are locals, while the other 3 officers are from outside of the local area. We'll have to accomplish this in steps by computing the number of ways that we can select the president and vice president from the pool of 65 locals in the organizational membership, And then the 3 other officers will select from the 14 people who come from outside of the local area. The multiplication rule tells us to multiply these 2 quantities together, giving us the total number of ways to select 2 officers, the president and vice president, from the local area, and 3 officers from outside the local area. Once we have this quantity, we'll divide it by the total number of ways to select 5 people to serve as officers from the total membership of 79. So to accomplish this task, we'll make use of the TI calculator's NPR function found in the math probability menu. And we'll use it first to calculate 65 NPR 2. Now unfortunately here I accidentally entered a 5, but I realized it while I was typing the input, and I go back and edit it using the arrow and delete keys to overwrite the 2 and do the correct value. And I multiply that quantity by 14 NPR 3, the number of ways we can select 3 officers from outside the local area. Then finally, I divide that quantity by 79 NPR 5, or the total number of ways we can select 5 officers from the membership of 79 people. We see the probability comes out to 0.3%, a little over. Next, we'll work on an example that involves combinations rather than permutations. And this is appropriate in situations where we are selecting some number of things from a larger group in which the selected items do not play distinct roles, or they don't get arranged into a distinct order. So in this example, we look at a standard deck of 52 playing cards where there are 4 suits of 13 cards each: hearts, diamonds, clubs, and spades. The hearts and diamonds are red and the clubs and spades are black. And within each suit there are 10 numerical cards, ace through 10, and 3 face cards, jack, queen, and king. We are tasked with determining the following quantities and probabilities. First, we'll want to know how many ways we can select a hand of 5 cards from a standard deck of 52. After that, we'll want to know the probability that our selected hand will consist of nothing but spades. Next, we'll want to know the probability that our hand will consist of nothing but face cards. And then lastly, we'll want to know the probability of selecting a full house. Computing combinations on the TI 83 Plus and 84 Plus calculators is very similar to computing permutations. We'll find that there is an NCR function within the math probability menu rather than the NPR function that we use. So, in order to compute the number of ways that we can select 5 cards from a standard deck of 52, we'll just need to use the NCR function in the calculator in order to compute 52 choose 5. So here we do that by opening a parenthesis, typing 52, and we select NCR from the math probability menu. And we enter 5 and close off the parenthesis. We see a fairly large number of possibilities. In order to figure out the probability of drawing a hand that consists of nothing but spades, we've got to recognize that there are 13 spades to choose from. So we compute first the number of ways to select 5 cards from the 13 available spades, and then we'll divide that by the total number of ways to select a hand without restriction, the value that we computed in the previous example. So we begin by entering in 13 NCR from the math probability library, 5, and then we divide that by 52 NCR 5. and this results in a fairly small probability. The task of determining the probability of selecting nothing but 5 face cards is similar. We just need to realize that there are only 12 face cards to choose from. So we've got to count the number of ways with a combination of selecting 5 face cards, and then divide that by the number of ways of selecting 5 cards without restriction. We can accomplish this by copying our previous input and editing it so that we are selecting the 5 cards from 12 rather than 13. This results in a slightly larger probability. In order to determine the probability of selecting a standard scored poker hand, something like a full house, we've got to think a little bit harder. Specifically, we've got to think about the tasks that we would have to undergo in order to construct a full house. So first of all, we'd have to decide what value of card the 3 of a kind is going to be constructed from. Then we'd have to decide what value of the pair is going to be available to us. Then we'd have to decide what cards are going to populate the 3 of a kind and what cards are going to populate the pair. These are 4 decisions that we'd have to make in sequence, and the multiplication rule would tell us to determine the number of ways we could make each of those decisions and multiply them together in order to count up the number of ways to compute or select a full house. Once we've done that, we would just divide that result by the 52 choose 5 number of ways we could select an unrestricted hand of cards. To accomplish this on our calculator, we'll need to realize that there are 13 values that we can use to populate our 3 of a kind. Then there are 12 remaining values that we can choose to populate our pair. And then there's going to be 4 choose 3 or 4 NCR3 ways to form our 3 of a kind of that chosen value. And then 4 choose 2 ways to form the pair of the other chosen value. If we multiply all of those quantities together, the multiplication rule tells us that that's the total number of ways that we can form a full house. If we divide that by 52 NCR5, then we'll arrive at the probability of selecting a full house, or a little over 0.14%.